the implementation of signal flow to obtain transfer function of a control system. So we'll explain a line by line the MATLAB code along with the mathematical explanation. So first we'll consider here the diagram like this. First here a forward path, one forward path followed by individual loop 1 and loop 2, right? So here for the loop 1 we'll be having a1 as 1 and b1 as minus 1. For the loop 2, a2 as 2 and b2 as minus 2, right? So simple MATLAB code. So here a1 is defining the first here a1 and a2 is this one, a2 2, b1 is minus 1, that is feedback path of loop 1, b2 is minus 2, that is feedback path of loop 2. Then we'll write the delta function 1 minus of b1, that is here we'll write 1 minus of b1 and delta function 1 minus of b2. You will understand these two lines in the next path. So it's a Meson gain formula. So a1, what is a1? It's the first forward path, so it is almost equivalent to this one. So here can look at this portion. Meson gain formula G equal to T1 delta 1 plus T2 delta 2 divided by delta T1. What is T1? T1 in this case it is nothing but A1, right? So that is this path. Next, what is here T2? That is in this case it is A2. Here this path. First path you can consider like this and other path we can consider like this. This is what I have just forgotten to write like this. Right. So this should be like this, not like so. This is the first forward path. This is like this A1, and second forward path is like this A2. So here based on that T1 delta 1, T2 delta 2 divided by T. So in this T1 and T2 are T1 is A1, T2 is A2. So delta 1 and delta 2 I will explain, right? So before that just look at this. This is a Meson gain formula. One is A1 followed by this 1 minus of B2, A2 followed by 1 minus of B1 divided by delta, right? So that delta is in this formula, this is a delta. Then display Meson gain formula, mathematical analysis. For this diagram, how many forward paths are there? Two are there. One is this path x1 a1 and x2, and other is x1 a2 x2. So here a1 and a2 you note down. Forward path gain, what is the gain of this first forward path? It is 1. So what is the second forward path gain? It is 2. Then loop gain is, this is b1 equals to minus 1 and b2 is equals to minus 2, right? So next here delta 1. How to calculate delta 1? So with the help of this formula. So here delta equal to 1 minus of individual loops, sum of individual loops, and here the product of the loops. So delta is equals to, this denominator is this part, 1 minus of sum of individual loops and the product of loops. But how to calculate delta 1 is, look at this, delta 1 stands for this forward path, first forward path. How many loops which are non-touching to this forward path? That is this one, L2. So L2 corresponding to what? B2. That's why we have written here 1 minus B2. Then how to write delta 2? So now we should see this path. How many loops which are not touching to this? Is obviously this one. So this is not touching, it is corresponding to B1. That's why we should write here 1 minus B1. So 1 minus is common, 1 minus is common. So if it is a path 1, so you should write the non-touching to the second one. If it is a path 2, non-touching to the path 1. So that's what we should write delta 1 and delta 2, which is to be substituted here. Then Meson gain formula, the same formula which we have used here, right? So start substituting in this A1, 1 minus B2, A2 and B1. So at the end you will get what is delta. Delta is calculated by this formula. Delta L1, L2, L1, L2, you know everything. Start substituting here. So you will get delta is 6, right? So once you get the delta is 6, substitute in this delta is 6, right? Substitute delta is 6 in this, so that substituting you will get G is 1.16, right? So after this you will get the output as 1.16. So that we should cross check with the help of this signal flow graph, the same code we have written here, and save this and run. So after running, so you will see the result, right? So here you will get the result, which is going to be exactly matching with this code. right? So that's how you should do the implementation of signal flow graph to obtain transfer function of a control system. Okay, thank you. We'll see you in the next video.